Today I'm mainly just going to be reviewing over power, because it seems like a lot of people aren't exactly like solid on power, so a lot of people are having trouble on that one. And I mainly sort of I wasn't very thorough with it in 2022 because I thought that most people had gotten an idea of power. So I so I'm just going to go over the concept of power and then solve the 2023 power question. So the way that we usually do in DC, oops. So in DC, usually we have that a power is I times V. That's not it in AC, obviously. Really, the main formula that you need to know is that really there's one formula, one big formula that you need to know for power is that complex power I'm going to write as S. So S is equal to I RMS, V RMS, the magnitude of each, multiplied by each other, at an angle of the voltage angle minus the current angle. That's pretty much the only formula that's really important. Everything else stems from this. Everything else stems from this. How do you find S? It's right here. This is complex power. This is complex power. So complex power is the magnitude of I RMS, the magnitude of V RMS, times the magnitude of V RMS, with an angle of the voltage angle minus the current angle. Yes, but last time you found I by dividing S by V. Which value is S? It's right here. That is S. You can rearrange this. Yeah, it's absolutely. I'm a bit confused by your question. Last time you found I by dividing S by V. Yeah, so the magnitude of S is the magnitude of I RMS times the magnitude of V RMS. So you can rearrange this equation. It is in equation. So S divided by the magnitude of V RMS is equal to I RMS, or the magnitude of it. Like in terms of the question you did, how did you find S based on Q5 for 2022? Okay. I'm going to get to that point. I'm going to get to that point. Don't worry. So the second part that splits out from S is that the real component of S is the average power. And the imaginary component of S is the reactive power. This is average power. This is reactive power. And finally, the magnitude of S is the apparent power. So I made this mistake last time on question 5. Apparent power and complex power are very easy to mix together, but they are different because apparent power is just the magnitude. And one of the important things as a result of that, while you can add complex powers together, this is allowed, you cannot add the magnitudes of them. This is not allowed because you will get two different answers. Basically, what I'm trying to say here is that the sum of the magnitudes is not equal to the sum. This is not true. Yo, potatoes, yes. What do you need? If you find me after exam, I buy you dinner. Alright. So, this is the main, this is pretty much the main equation. There is another one. The second one is that this angle is also equal to, for example, there's two ways that it's written out. The power factor. So power factor. For example, you could be given leading, say that you have some S, the apparent power, leading 0.6. So this will appear on the question. It is in the 2023. If we look here, you get 0.8 power factor leading. What this means is negative cosine inverse of 0.6. The angle of S. Let me write that down. The angle of S is equal to negative cosine inverse of 0.6, which is also equal, again, to the angle V minus the angle I. So lagging is positive. Yes, correct. So if I have lagging 0.6, again, same thing here. This is that the delta, the angle of S is cosine inverse of 0.6. And again, that's still theta V minus theta I. This also occurs when, what's that? Angle V is bigger than angle I. This occurs here when angle I is bigger than angle V. That isn't that important, but I'm just trying to connect these mathematical relations together for you. That is apparent power. So we sort of draw power in what we represent power in what we call a power triangle. The power triangle is literally just phasor form. That's it. If I draw it out, it is the imaginary component up here, the real component up here. Oops, I just realized I made a mistake here. The magnitude of the imaginary component is the reactive power. So if I didn't have that, you would write reactive power as like 100 J kVAR. It's just 100 kVAR. VAR. Oh yeah, let me write that down as well. So this is measured in watts. Oops, this is getting too long, so I'm going to move this to the right. This is measured in watts. This is measured in voltage amp resistance. And this is measured in voltage amps. Because they sometimes don't tell you that this information. They don't tell you it's reactive or apparent power. They just say VAR or VA. So the power triangle looks like this. You have the imaginary axis here, and you have the real axis here. This is real. And you have, sorry to interrupt, but is this being recorded? It is. So I will be uploading it, don't worry. So this is your complex power. It is made up, okay. It is made up on this end. This is the reactive power, and this is the power average. And this here is theta S. So this is our power triangle. And again, this is literally just angles. This is a triangle. There's nothing special about it. It works exactly just how every single other triangle works in existence. The only difference is that this way is imaginary and this way is real. And that's pretty much it. This is the only other thing I can think of is that VRMS is equal to V over root 2, and IRMS is I over root 2. Oop. Oh. And power is always additive. Always additive. Additive. And never add apparent power. Never add the magnitude of powers. So what I mean by always additive, this means doesn't matter if series or parallel. You add them. And apparent power is never added because, again, you don't add magnitudes. You add the actual vectors. And yeah, that's it. That's all that there is for power. So everything else follows afterwards. Let's give an example, or let's do from 2023, question 5. So this is a power question. So this is actually harder than the 2022 exam, in my opinion, because you're not actually given the voltage across these two. You have to figure it out, but it is possible. You can first of all, let's think of a game plan for this. You can find the voltage because you can find the resistance of these two loads. Actually, can you? I don't entirely know. I'm trying to think because I'm doing this question off the top of my head. So this is one that I haven't actually seen before. The one where they don't actually give you the voltage, but they give you the current across. But we can just try it, really. So let's see. Calculate the total apparent power. At the worst, we're just going to do up to 4. To calculate the total apparent power received by the load A and load B. So the really important information is written up here. Let's write that up. Let's take that down here. Load A is inductive and receives 45,000 VA and kVA and 36 kVAR. Would inductive change anything? Yes, yes, kind of. So it should be part of the question. So when someone says kVAR, so say 36 kVAR, this implies it is inductive. A positive reactance is inductive. If you have negative 36 kVAR, this means it is capacitive. So positive kVAR is inductive, negative kVAR is capacitive. I don't know whether they will write something like capacitive and 36 kVAR. What this is saying is just negative 36 kVAR. I don't know if they'll do this to you. I don't think they will. That's kind of dumb, but keep an eye out for that. If it says capacitive and say 36,000 kVAR, that just means it's negative. But yeah, good question, good question. So, let's assemble the power triangle. Once again, you have your S here. Oops, I can't draw a straight line. There you go. So here's our S. We don't know it yet. Okay, let me write load A. We don't know our S yet. We don't know our theta yet. And on our imaginary side, we have Q. And on the real side, we have PAVE. We know Q and we know Q, we do know S. Sorry. Capacitive is just when you flip the sign for VAR. Yes. You'll notice in every single question, capacitors are always a negative imaginary number. Inductors are always a positive imaginary number. That's like the relation between the two. They are opposite in equals. Yeah, that's a good thing. That's a good example. So let me just show that. Um, the capacitor, right, is 1 over JWC or JWC or negative 1 over J over WC. So that's always going to be negative. The inductor is JWL. That's always going to be positive. So load A is inductive and receives 45,000 kVA. Again, this is S, right? This is our parent power, 45,000 kVA, 45K. And this here, VAR, let me just show that here. Apparent power is measured in VA. Reactive power is VAR. So 36K VAR, this is our reactive power. So let's write that down. 36K, we don't need the units. We can drop units here. And so we have built our power triangle. Calculate the total apparent power. Okay, so we do need all three. And again, this works the exact same way as all other triangles do. So P average is going to be the square root of S squared, S squared minus Q squared. Again, this is triangle. This is just trigonometry. I hope you know where this formula comes from. So if we write that out, we get that P average is going to be equal to, let's put that into our calculator. So that is 45 squared minus 30 squared. You get 33.54 K watts, kilowatts. So there you go. Let's write that down. 33.54 kilowatts. Just K. And again, this is a triangle. You can verify this. Put in your calculator 33.54 squared plus 36 squared, and you will get 49. Or sorry, what? Did I put into my calculator wrong? That's impressive. 33.54. Oh, this is 30. Oh, I put in 30. There you go. 36. I can't draw for the life of me. Yeah, so this is going to be 27,000. See, that's why you verify. And again, put it back into your calculator. Put into your calculator 27 squared plus 36 squared, and you'll get 45,000. All right, now let's find load B. Load B. Load B receives 70,000 kVA. This is our S, our apparent power, magnitude S, and 0.8 power factor, leading. This means that theta S is going to be less than 0. It's going to be negative, and it's going to be and that theta S is going to be negative cosine of our number here. So let's assemble our triangle. So we have our triangle here. This magnitude here is 70,000. Let me write S. Would it be just cosine of x if it was lagging? Yes, it would be. Oh, sorry, this is cosine inverse. Cosine inverse, sorry. Yeah, just here's the formula. Leading, it's negative. Lagging is positive. Wait, what? Yeah, leading is negative. Lagging is positive. Wait, since it's leading, shouldn't the triangle be pointing down? You are correct, and I'm forgetful. I told myself I would do that, but I forget. Okay, here. Thank you. S is 70,000. This is our theta S. This is our Q, and this is our P average. So theta S, let's put that into the calculator. So that's negative cosine inverse of 0.8. That is negative 36.9 degrees. Yeah, 36.9 degrees. So, again, this is just trigonometry. This is a triangle. There's nothing special about it. So now we can do that using our trig relations. We have, what's that? Sine theta is equal to opposite over hypotenuse, or that the hypotenuse equal opposite, or that s times sine of theta is q. And likewise, s cos of theta is p average. So let's put that both into our calculator. So we have 70,000 times sine of negative 36.9 is equal to negative 42,000 and 70 times cosine of negative 36.9 is going to be 56,000. Wait, sorry, how did you get the angle again? Yeah, no problem. I probably should have written that down. Let me move this down a bit. So we're told leading 0.8 power factor. This translates into negative, that the theta s is negative cosine of 0.8. This leading here is at negative. Is that clear? This is negative 36.9 degrees. All right. So now we have our full triangle here. So this is Q, so that's negative 42,000. And this is P average, which is 56,000. You're in radians. you will get the same answer in the end, but generally we work in degrees. It also makes it more clear what's going on. But yeah, just in the exam, keep your calculator in degrees. Don't torture yourself. It's easier if you just keep it in degrees. Okay, so now we have load A and load B. So now the questions. Let me copy them down here so that I can answer them a bit more clearly. Calculate the total apparent power received by load A and load B. So again, let's look here. Power is always additive. You always add power except for the magnitude of apparent power. You never add apparent power. You can add complex power, but you can never add apparent power. So let's make our lives simpler and let's just add the complex power. Because again, the complex power contains the average power and the imaginary power, or the reactive power. So that is that the complex power is the magnitude with an angle of theta s. That's it. So this is going to be equal to, in this case, 70,000 at an angle of negative 36.9 degrees. This here, so S is going to be, again, magnitude of S with theta S. That's going to be 45,000 at an angle of, how do you find the magnitude of S? It's a triangle. So in this scenario, we're given both magnitudes of S's. Again, kVA or VA is magnitude or apparent power. So we're given them. But otherwise, again, it's a triangle. If you're given the apparent power, if you're given the average power and the reactive power, again, it's a triangle. What's the name? Pythagorean theorem. You can use that. It's a triangle. So this theta s, we can find the degree in many ways. Let's just do that tan inverse of, what's that? Opposite, which is 36 over 27. So that's 45,000. Tan inverse of 36 divided by 27, opposite over adjacent. You get 53.1 degrees. Again, this here is the Q, this here is the opposite, and this here is the P average, or the adjacent. You could also put that into your calculator as polar form and convert it to rectangle form. Yeah, absolutely. Again, phasor form is a triangle. Phasor form is also a triangle. And rect form just gives you the components of that triangle. So let me show you it right now. If I go into my calculator and I put in 45,000 with a phase angle of 53.1 and I turn it into rect form, I will get, I will get 27,000 plus 36,000 J. See? That's P average. And that is Q before the magnitude. Q is 36,000. Or this is just QJ. So again, it's a triangle. Understand phasor form, understand rect form, what they are. They just work in triangles. Everything's a fucking triangle when you go down far enough. So we have that our apparent or our complex form for A is 45,000 with a degree of what's that? 53.1? Yeah, 53.1. 53.1 degrees. So is S P average plus QI correct? Yes. And you know, I'll write that down here just to make it very clear. It's also equal to P average plus QJ. Do I get sicker? No. You're punished for good behavior in here. You're getting timed out for half an hour. So to get total apparent, would you do SB plus SA plus SB? Correct. Because again, this is complex power, not apparent power. So 70K, phasor of 36.9. You can add complex powers. So S total is equal SA plus SB. So let's put that into our calculator. It's 45,000 with a degree of 53.1 plus 70,000 with a degree of negative 39.6. Let me put that into polar form. And the answer would just be your magnitude. Yes, for apparent power. So that is 83,000 or 83.2 thousand with a degree of negative 4.16 degrees. So our magnitude S is equal to 83.2K. This is our apparent power. So let me just write VA. This is our apparent power. And again, this is a triangle. So we can add them up in phasor form. Correct. Yes. So let me show you how this doesn't work for magnitudes. If I wrongly state that the apparent power total is equal to the apparent power A plus the apparent power B, what am I going to get? I'm going to get 45,000 plus 70,000. That's 115,000. You can see these are not the same. And that's what I'm saying, or that's what I was saying, that S1 plus S2 is not equal to, or the magnitude of that, is not equal to the magnitude of S1 plus the magnitude of S2. They're not the same. And if you want a visual representation of that, if you have S1 here, and then you have S2 like this, or S2 like this, this will be your S total. that's not you again. You can't just add the magnitudes. I believe we've done this in like PCS 211, right? You can't add the magnitudes. You have to add the vectors. So this is our apparent power, and now we can just break this down into rectangular form to find the components. So S is going to be equal to we did that part out. S is going to be equal to 83.2 thousand with a phasor of negative 4.16. If you put that into rectangular form on your calculator, you're going to get 82.98, that's 83, minus 6J. And again, this is P average minus QJ. So, P average, that's 83,000. Oops, there's 1,000 in here. 83,000 watts. And our reactive power is going to be 6,000 voltage amp resistance. That's it. And we can prove this by, again, you can add any power except apparent power. So let's try adding the other stuff together. Here we have 27,000, 27 plus 56,000. That's 83,000. Here we also have 36,000 minus 42,000. We get negative 6. Oopsies, I'm blind. Negative 6,000. Negative 6,000 apparent power. Or sorry, reactive power. Again, I mix them up all the time. So, that's an example on how to calculate the apparent power, the average power, and the reactive power. That's the core of it. This page alone pretty much summarizes all that there is with power. With complex power, with apparent power, with average power, and what do you call it? Ugh. Oh yeah, there's also like one thing. Sorry. Yeah, that's and complex. I think I said them all. Yeah. One other thing, by the way. This is also going to be needed for Thevenin. That the P average is equal to the VTH square over 8 RTH. You're going to need that for Thevenin. I did that last on question 4, I believe, for the Thevenin question. You're going to need it. But that's only for Thevenin. So, that's 1, 2, 3. Okay, and the final one, 4. Calculate the total power factor for the combined load A and load B. So recall that the power factor is going to be cosine inverse of our angle. Or sorry, not even our angle. So our theta S is equal to cosine negative 1 of our power factor. Actually, an easier way to remember it, let me rewrite this because it's easier to remember. Leading means negative in here. Like so. That should be the same answer. Let me just triple check because I am, you know, you never want to rely on pure chance. Cosine of negative x and negative cosine of x. Oops, that's a cosine inverse I'm trying to get here. Is that the same? No, it's not the same. Okay, never mind. Don't do that. Oopsies. Yeah, just remember it like that. So, r theta s is equal to cosine inverse of pf. Now, our degree s is negative, which means this negative here means that we are ultimately, what's that? We are leading. We are leading, yes. We are leading here. So this is going to have to be negative. And now we just algebra. This is just algebra. So cosine of 4.16 is equal to a power factor of 0.9974. Yeah, it's pretty skewed. But 0.9974, and again, this is negative, so it is leading. Let's just confirm that. We're going to, let me save that into a variable on my calculator. Negative cosine inverse of that is going to be negative 4.16. Is the angle 4.16? Yes, but we are doing cosine negative 4.16. Let me just put that the other way around. Sorry, I should have been more clear on that part. So that goes down there like that. So, and we have our power factor. So that is 4 questions down. See, power is not that hard. It seriously is not that difficult. What does I mean? I. Where's I? No, in general, like I star. How long has the call been up for? It has been up here for since 610. I star is IRR. That is an engineering economics term. That's not IRMS star. Where do you see I star? Because I don't recall ever seeing that. Oh, I don't know. I don't really see how it's any like different really. I've never seen I star been used. Does Andy use that? Oh, that's what makes a negative angle in your S formula. Oh, it's a complex conjugate. Yeah, I guess so, but like you don't need to use it really. I wouldn't use it anyway. So I star is literally just it's a conjugate. Is the angle always going to be negative? No. Let me see. I start. That's what makes an. Because usually, if you're finding the magnitude anyway, whether or not the angle is negative or not doesn't matter. Is it depending on lagging and leading? Okay, so these two are directly related. If your final answer has a negative sign, has a negative sign, that means it's leading. If it's positive, that means it's lagging. All that affects is all that really affects is this negative sign here. When you multiply two polar numbers, you add the angles. Because of the star, you subtract the current's angles. Yeah, that is true, but that's why we write out the formula differently. Like here. Like, yes, you could write that as S is equal to IRMS star VRMS, but that it's the same formula. These two are the same formula. You can remember it either way, but just not to confuse people, I want to just keep in one form, and I think this is the one that most people are familiar with. It's the magnitude of IRMS times the magnitude of VRMS with an angle of theta V minus theta I. So if the triangle points up, it's lagging, and if it points down, it's leading. Correct. Yes. You can see here, this here is lagging. Theta S is positive. and this here is leading. It says right there. Theta S is negative. And again, if we look here, this is leading because theta S is negative. So we put that into our equation, and we find our power factor. That's pretty much all there is to remember about that part. So, is there any other questions, or? Because the angle of S is negative, because leading and leading also makes cosine of -1 negative. Does that mean it's always going to be positive? Huh? Because the angle of S is negative, because leading and leading also makes negative. Does that mean it's always going to be positive? I don't entirely get your When do you get the complex conjugate? I don't. I don't get your question for. I don't get your question. Konkan Lan's illegitimate son. Is that legit all for power? Pretty much. Like, that's pretty much it. You named yourself that. That's not my decision. All right. So now I didn't think power was this light. Yeah, it's. Does it matter if it's cosine negative theta or just cosine theta? I believe that nets you different answers. Let me put that into Desmos here. Yeah, that's. Oh wait. Oh, yeah. Okay, so it doesn't really matter. I'm just doing algebra here. It's like, yes, you can just skip that, go directly cosine 4.16, but algebra. Keep it to algebra. You're gonna get the same answer anyway. Will we lose marks if we don't put the negative? I doubt it. No. You're just skipping a step. It doesn't matter. Is it going to be recorded later? Yes, it will. I am already recording. Okay, I don't. Oh wait, yo. Is there something else? Did you just transfer the negative over? Yes. Again, this is just algebra. So you move over the negative, you move over the cosine, yada yada. You're not doing question 5 or question 6. This is question 5. I'm not doing. There is no question 6 though. This is the last question. Does a phasor voltage and current not matter? I'm not sure what you mean. Are you saying that the degree of the voltage doesn't matter? No, because if you look here, these two are the. This is the degree of VRMS and IRMS. Are you going to do part 5 and part 6 for this question? I don't know. I will be honest with you. I'm not entirely sure how you'd go around solving 5 and 6. I don't think I've ever seen a question like this. Let me see if there's something else I missed from this here. Yeah, I'll be honest with you. I'm really not sure how you're supposed to solve 5 and 6. Did we not use 180 degree 0 on this part? I'm not sure where 180 with the degree 0 comes into play here. Okay, so we did not use? I guess not. I'm not sure. Where did you get 180 with a degree of 0 from? I'm just wondering when we use it. Yeah, but I don't know like what you are, where that came from. The current leaving the voltage source. Is that mentioned in the question? Oh, the current. Yes, that's for 5 and 6. Again, I'm not entirely sure how we're expected to solve this, because from what I'm looking at it, Z is not exactly solvable. So the impedance for either of these is not really solvable. Power is... I don't know. I've never seen a problem like this before for power. Oh, someone did a thing on it? Let me see. VRMS equals... Huh? Andy's solution. Oh dear. Oh dear. So this is like huh. Okay, I don't know where you pulled the 2 from. So, thank you for attending the tutorial. That's really all that I want to cover. So again, I'll try 5 and 6 later. I'll see how it comes out, but I don't know how to solve it at this moment. But this is I'll upload this PDF as well. And again, I'll upload the video. So I'll see you all. Thank you all for attending. Have a great day and good luck on the exam. Godspeed with you all.